In a software engineering interview, you'll probably be asked some variation of how would you build this system? Today, I want to do the opposite. Let's take a look at this architecture diagram from Designing Data-Intensive Applications and think of an application that this diagram might be describing. So we have a client making some kind of requests via some gateway API to some backend code. The backend is doing a few things. First, let's focus on these reads and writes. So we know this is an application that is both reading and writing data. For reads, we're first checking against a cache to see if the data that we're trying to read has already been retrieved, perhaps in a previous session or search. If it's not there, we'll need to read that data from the primary database and update the cache. We also have something which is writing to the primary database. Additionally, the user can search. Any search requests go to a dedicated full text index, which will presumably then send the search results back through the application layer and display the search results on the client. It should also be noted that for the write operations we previously mentioned, any new writes will also update the full text index database and apply these updates to any future searches. Additionally, there are some asynchronous tasks which the user triggers, which updates a message queue, which is eventually processed by some application code and performs these async tasks, for example, sending in email or push notifications. So if you've been watching so far and you're scratching your head and saying, hey, but CodeTour Chris, this is a standard pattern which could describe just about any web or mobile application. Well, ding, 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 you are correct. So when I was first looking over this diagram, the first thing that jumped out to me was the search. And that got me thinking about how this could describe, some common searching on like an e-commerce site like Amazon. So when you're using Amazon, let's imagine that we're looking at the page for all dog food. This is the first read operation. So the application layer looks into the cache to see if we've made any requests for all dog food products in the past. And if this data exists in the cache, it'll immediately return that to the client. And if it doesn't, then it'll go into the primary database to retrieve all products related to dog food, return those results to the client, and also cache those results. Now, what happens when we want to buy a product? Let's say we add this Blue Buffalo to our cart. Well, when we add Blue Buffalo to our cart, we're performing a write operation. We're basically telling the primary database, hey, in whatever table represents items that are currently in my cart, I want you to add a record for Blue Buffalo. Later, when we actually buy the product, that record will get added to some table of products that you've bought in the past. But now let's say that Amazon gets a little smarter about the products that they want to show you. The next time you do a search for dog food, Amazon makes sure to show you Blue Buffalo as the first item because they know that you already like this product. And by making sure that you know that they have it, you're more likely to buy it. That's this whole process. When you made a write to the database table for products that you've bought in the past, that change was also captured and also sent to the search database so that the next time you make a search for dog food, you'll get a smarter dog food result based on the products you already like. And finally, we can imagine that as we are buying things, some asynchronous process is kicking off, which will send you push notifications to your phone or email to let you know that the product that you have bought is in transit or has been delivered. So if you like these type of sort of bite-sized system design videos, let me know in the comments what you would want to see next, and I'll see you in the next video. Thanks for watching.